Hello friends, good afternoon and welcome to EduSat Live Lectures. Dear friends, today we are going to talk about principles of software engineering. To discuss this topic, we have with us our subject expert, Mr. Anikulmar Mishra. Mr. Mishra is assistant professor in a very prominent university. Without further ado, I would like to welcome sir to our studios and request him to start the lecture. Welcome sir.
Okay, thank you ma'am. So, good afternoon my dear students. So, today we will discuss about some of the basic and eminent concepts of software engineering. So, the first thing, engineering means traditionally it is related to manufacturing. Whenever we say engineering means it is related to manufacturing in the classical sense. For example, we manufacture highway, automobile, building, chemical engineering, like that. But it is a very new concept that the engineering concept is applied in the case of software at the time of creation of software. Earlier we have made software without the concept of engineering. So, do you know why the engineering approaches were necessary to create the software? Because can you create the building without engineering approach? Yes, we can create. Even in the villages, we create the building, even small roads without the help of engineering approaches. But what happens if you have to create multi-storage building? And what is the lacuna in that approach? The lacuna is that at the time of creation of the multi-storage building, on the 5th floor, you come to know that there was some problem. Then can you backtrack? No, you cannot backtrack. Similarly, at the time of when the software is very voluminous, and if you want to incorporate any change, then if you have not created the software through the engineering approach, then it is difficult to, you have only one way to throw the software. So, engineering, all the engineering approach means from planning to creation, implementation and the delivery. There are sets of steps which are predefined, and through that process the software is created. Software crisis is a basic term. Software crisis means these days, day by day, the hardware are coming up, new hardwares are coming up. You may see that the cost of the hardware is reducing day by day, and the number of software users are increasing heavily, exponentially. So, the software cost is decreasing, the hardware cost is decreasing, and the software users are increasing exponentially. So, this term, because maintenance has become a problem. If these days in a house, even the housewife, kids, senior citizens, they are using the computers for different purpose. So, who will maintain these softwares? So, this situation is called the software crisis, and through engineering approach we could solve the software crisis problem. Now, there are two things at the creation of software. One is called software product and the other is software project. There is little bit difference. What is the difference? Can you say? The software project means the projects have the dedicated customer. For example, the TCS, Infosys, they are the vendors and they have the client like Maruti Udyog, ICICI Bank, syndicate banks. So, the software vendors have the dedicated client, and they have to solve the particular problem, they have to automate the systems. So, cash flow is not a problem in the case of software projects. So, they are creating, the vendors are creating the projects for a dedicated customers. So, they know the cost in advance. And for products, for example, Microsoft Office, Windows, Linux, they are the products. So, if you do not want to use Microsoft Office, nobody can force you. These are called the products. Product means they have to capture the entire market. So many products came in the market, they could establish themselves for some year, then they were thrust out of the market. There are so many products. So, product means no cash flow, all the investment is done by the software company only. Project means they have the dedicated customers. So, basically the engineering approach in software is different because in the other types of engineering we have so many things visible, but in software everything is intangible. So, cost estimation is difficult in the case of software. For example, in the case of building, you know the cost of the cement, cost of the bricks, cost of the iron. So, the estimation is quite simple. The agreement or contract negotiation is visible, but in the case of software it is not visible. So, because of the unique characteristics of the softwares. So, among many unique characteristics, these two are very prominent. For example, software is intangible, you cannot touch it, and it does not wear out. Wear out means any hardware product you name, it has to die out after certain period of time. You can see. So, initially when you will create any hardware, for example, a table or a building or a road, so it will take some time to settle down, and after that the useful life starts, means that project will remain there for that period of time, for the useful life period, and after that the project has to wear out, means now project is cannot be used at it has been used earlier. So, this is the life cycle. The useful life cycle, lifetime period is the main period where the product or the project gives maximum efficiency. And of course, the maintenance is of different kind in the case of other products. For example, if some of the ingredients or the parts are repairable, so that is replaced, which is cannot be done in the case of software product or the software project. Because suppose if we have written a program today, that program will remain there throughout the life cycle, throughout the period. Nothing will happen with that program if no decay will happen with that program. So, that program will remain there. So, software does not wear out. Whatever you have written, that will remain there, it will work as it is, but it deteriorates. So, you can clearly see the failure rate when we write the software. Initially some failure comes, when it settles down, this is the idealized curve. Idealized curve means it can be used for the same purpose in the same way, no decay, but because software is developed for the business, to automate some business. So, you need to, because whenever the business will change, you need to incorporate that in the software. That is the requirement, because software maps the business and there are lots of changes in the business. You take example of any business, for example, banking business. Earlier we had national bank only, today we have international bank, Grameen bank, cooperative bank. So, their requirements are different. The loan percentage changes day by day. So, you have to incorporate that change, otherwise you cannot incorporate that thing in your business. So, the software will remain there as it is, but because it maps the business, whenever there would be changes in the business, you have to incorporate that. So, there should be some facility in the software engineering, so that the deterioration can be taken care of. So, software development life cycle. Life cycle means till the software is created, the day from when the software starts getting created till the software is able to be deployable, that is called the life cycle. Software development life cycle means from the date when the software phases starts till the date the software phases completes. Now, it is ready to be delivered to the client, it can be used. That is the meaning of software development life cycle. So, now during how can you create the software? There are different phases in the software development life cycle. For example, for any software you have to gather the requirements, that is called the requirement gathering phase. Then you need to analyze those requirements, that is called the analysis phase. Then you need to make the design documents, high level design documents as well as the low level design documents, and that is called the design phase. Then you need to have the implementation phase, that will include the coding and the testing phase. Then you need to have the maintenance phase. So, these are the standard phases of software development life cycle: requirement gathering, analysis, coding, design, coding, testing and maintenance. So, now there are many ways to create the softwares, and all those ways can be categorized in two broad category, that is, one is the conventional way, other is the unconventional way. So, for a scratch project, even now the conventional way is preferred, and for the maintenance project the unconventional way is preferred. So, when you develop the software through the conventional process model, that is called the conventional way. When you develop the software in unconventional way, that is called the unconventional process model. Among the conventional process model, we have build and fix model, classical waterfall model, modified waterfall model, prototype model, evolutionary model, RAD model, V-shaped model, spiral model. And among the unconventional model, we have agile programming, component based model, formal method, concurrent method, aspect oriented software development. Now, build and fix method is the basic model. Suppose for a small vendor, if they want to create the system for their billing, then they do not have capacity to outsource their project to the big vendor. And so, build and fix model is a small team of software people, they create the software, they fix the bugs through the consultation with the client, and they do it on the daily basis till the software is created. So, this is called the build and fix model. This is for the small project, still popular, much engineering approach is not used, but here we have some problem. The advantage it is good for the low budget project, but it is not, the ownership lies with the small team. So, whenever the team member leaves the projects in between, then project handling become difficult. So, through engineering approach, the basic model is called the classical waterfall model, and it is the base model of the software development. And in this classical waterfall model, first this is called the entry exit phase. First the requirement gathering would be done, then after the completion of the requirement gathering, design would be done. The analysis has not been highlighted here. The reason being, analysis is the intermediate phase, that is called the sandwich in between the requirement phase as well as in the design phase. You gather the requirement, then you analyze those requirements, then you create the design documents. You analyze the design documents, you create the requirements documents. Again, you analyze the new requirements gather and you create the design document till the design documents are the fine tuned. The output of the requirement is SRS document. This SRS document is not used by the team of engineers, that is used by the team of clients only. And SRS document is the outcome of requirement engineering, and that document is needed at the time of deployment or the installation. And design documents are the documents of the engineers, creators of the software or the implementer of the software, coder or the tester, they refer to design documents. There are two types of design documents, high level design documents and the low level design documents. And after the design documents, the coding and the testing is done. And at the time of coding, the testing which you do, that is called the debugging, that is a part of coding only. And after that, the independent test group that carries out the testing phase and to highlight the errors and produce the fault free software. After these phases, the software is ready for the deployment or the installation. This is called the classical waterfall model. In the classical waterfall model, the project control or the project management is very good, everything is transparent, but the problem is you cannot backtrack from next phase to the earlier phase, which prevents the software people to incorporate any changes. So, incorporation of any changes, which is the inevitable requirement of the software engineering, because from time to time the business changes, you need to incorporate those changes, which is very difficult. Then this is the problem with the classical waterfall model. So, we solve this problem through the modified waterfall model. In the modified waterfall model, what we do? We provide the facility to backtrack from one phase to the previous phase. For example, if you are in the phase of testing and then the team could realize that there was some problem at the time of requirements gathering, yes, you can backtrack. At the time of installation, if the team feels that some wrong requirement has been captured, you can backtrack to that phase and you can correct that. Of course, cost is associated, but the modified waterfall model is the popular model in the software company. It is not the case that a software is created through the one model only. A big software, high budget software is created through a set of models, but modified waterfall model is a popular model. Similarly, we have the V-shaped waterfall, V-shaped model. V means verification and validation. There are two terms, verification and validation. They are the part of testing. Verification is done manually and validation is done through the actual data. So, in the V-shaped process model or the SDLC model, what is done? The first, all the requirements gathered is verified by a team of expert, that is called the technical review team. Then after verification, that is validated. Then similarly, all the requirements, specification documents, analysis sort of things are verified, then that is validated. Similarly, the high level design, which is known as the architectural design, is verified, then that is validated. Similarly, the detailed design is verified and that is validated. So, there are different level of testing or the validation. For coding, the testing which is done, that is called the unit testing. After that, the integration testing is done on the design level. After that, the acceptance testing is done on the requirement level. Then final, the system testing is done so that the software created would be able to be fit into the system or not. So, this is the V type process model. Similarly, we have very good process model, that is the prototyping process model. Prototyping process model means this is the toy implementation of a big projects. When the team is not very clear about the solution, then they go for the prototype process model. When you have the clarity about the requirements, most of the time if the software project is so clumsy, so big, then there is no clarity about the project. Then to have the clarity, they opt the prototyping process model. Prototyping process model means first the toy implementation of the big project would be created, and there are two types of prototype model. One is throwaway prototype model, other is evolutionary prototype model. In throwaway prototype model, what is done? You might have heard the name of pilot projects. What is that? That is a prototype process model. In India, usually what we do at the type of contract negotiation, still we prefer the conventional approach. For example, a company, suppose example Maruti Udyog Limited, they want to automate their system. So, they will give the tender in the newspapers, then many vendors, software vendors will fill the tenders, then they will negotiate the projects and then they will outsource the project. This is the conventional method. But even final at the time of deployment of the projects, the team feels that they have outsourced the project to the wrong software company. But the solution is the prototype model. What in European and the American clients, what they do when they have little bit unclarity about the projects, what they do, they demand the toy implementation of the project, and that is called the pilot projects. They demand the small, they create the specification, smaller specifications, and they bring the pilot projects from the different vendors, and by looking at the quality of the pilot projects, they outsource the projects. And in the throw of a prototyping model, the pilot project created is thrown and that company is outsourced and they start the fresh project. And in the evolutionary prototyping model, they keep that, they do not throw away that prototype and they keep on evolving that prototype, and this way they create the model. So, whenever you have unclarity about the projects, go for the prototype model, and all the exercise is done at the time of prototype building. For example, you can see ki after specification of the initial version, the client and the vendors, they interact, they come up with the intermediate versions, and then again they develop the projects, and then the final version is created, prototype is created through the consultation of the client only. And we have another process model that is called the rapid application development. This is just reverse of the prototype model. When the team is very clear about the requirements, they are very clear ki what they want to have, then they go for the rapid application development. Rapid application development means the client want the project at the earliest. Means suppose if you want to project within 3 months or the 100 days, then it is possible through the rapid application development. Of course, the client should have the clarity about the projects, about the requirements, and what is done, because the vendor do not invest much of the time at the time of requirement gathering. So, they rather invest maximum time in the implementation, coding and testing, and what is done, they increase the team size of the coding and the testing, and it depends ki how early the clients want. So, for rapid application development, we have different, we use some tools also. For example, VC++, that is a preferred tool in the rapid application development. When the programmer do not invest much time in the style of programming, the environment should be generated. So, rapid application development means much of the time is invested at the time of coding and testing. They increase the length of the team size to finish the project early. Here in the rapid application development project, we do not emphasize much on the user interface also, and because of the early delivery of the software. So, till now what we have discussed about the rapid application model, we have discussed about the evolutionary prototype model, we have discussed about the V-shaped process model, classical waterfall model, and the modified waterfall model, and similarly we have, these are the preferred conventional models. And what the maximum software company does, they create their own process model, and it is not the case that any process model has been created without the justification. There is a body PMBOK, Project Management Body of Knowledge. You can refer to that site for the PMBOK, that is the site of UK, and their report says that 85% of the project fails. Project failure does not means that it has not been created, it is not technically fit. The project failure means either the project is over costing, or it has been delayed, it has been delivered late to the client side, or some of the requirements could not have been finished in the way as it should have been, as it was required by the client. Of course, it is the responsibility of the client to deliver the requirements, but it is also the responsibility of the software vendors to capture the requirements in the way the client wants. Basically, the clients are not the technical person, so the responsibility lies, or the onus of the responsibility lies on the vendor only, software vendor only. So, project failure does not means कि project has not been created, project is not technically fit, but project failure means either the budget is over costing, means suppose the vendor is charging 2 crore rupees from the client, but the investment in that project is 4 crore rupees, then that project has failed. And similarly, if zero deviation rule is followed in the case of project delivery, otherwise a vendor has to face a heavy penalty from the client side, especially in the European clients and the USA clients. So, process models, they keep the historical data about all the project, PMBOK, they keep the historical data about all the projects. So, there the throughput of the process model can be seen. Similarly, different vendors create their popular process model project wise, referring to these conventional process model. There are many conventional process model, those are called the traditional process model. But there is one common difficulty with the traditional process model. You see, these days the growth in the business or the change in business is manifold, and the business, even the businessman or the business horse are not aware that what changes they are going to face. So, day by day the new challenges in the business is coming up due to peer pressure in the business, due to international business, due to many things. So, a software should be adaptable. So, all the business should be incorporated immediately, and that is the need of the software. And you can observe in the common conventional process model, at the time of requirement gathering, you gather the requirement in any conventional process model, and till the delivery at the time of requirement and till the delivery a lot of time has been passed. So, the business requirements have changed. Suppose a project is deployable after 3 months or 6 months or 2 years in a heavy project, after 2 years the requirements get changed, then we need to incorporate those changes in the software. Means in the conventional process model, you need to revisit all the phases from requirement to design to implementation to test to installation. So, that is very difficult thing through the conventional process model. So, these days, especially in the case of maintenance project, maintenance means it incorporates all the phases again. In the case of software, in the case of hardware projects, the maintenance is of different kind. We do maintenance in as a form of repair, but here maintenance means whole SDLC, means to incorporate any change you need to revisit from the requirement, design, implementation, test to installation. So, maintenance is a complete SDLC, you can say. So, now what is the problem in the conventional process model? So, conventional process model is very good for the scratch project, but for the maintenance project it is not good, because the incorporation of changes is very difficult task in the conventional process model. So, we do not have a choice, we have to go for the unconventional process model. So, now we will learn the unconventional process model after some time. welcome viewers. Now in this session we will discuss about the unconventional software development process model. As we know that the biggest problem in the conventional process model is that for the maintenance projects the incorporation of changes are very difficult, which is need of the all the businesses these days. And there are two types of changes which is happening these days. One, business model is getting changed, and as well as there are lots of changes in the technology. For example, day by day the new programming languages are coming up, the new tools are coming up, the new hardware are coming up, the new development paradigms are coming up. So we have to gather all those things in our software development process. So that is best done by the unconventional process or untraditional process model. Unconventional means we don't follow any conventions in a rigid way. Following of the convention is not very rigid. So there are many and process model, you can see this slide. So in the traditional process model, what is done, initially the cost of change is low, but later on as the phases progress, for example, initially if we are in the requirement phase and in any conventional process model, and if you want to incorporate some change, then the cost of change is low. And as the phases progress, suppose if we are in the coding phase, then if we want to make some changes, then the cost of change is high. And when the software is deployable, at that time if you want to have some changes, then the cost of change is very high. So in the traditional process model, initially the cost of change is low, but as the phases progress, the cost of change is very high. So in the unconventional process model, it is reverse. So initially the cost of change to incorporate the cost of change can be high, but later on as the phases progress, that would be very low. So there are many unconventional process model. Agile is very popular among the software industries, and there are many agile process model. Extreme programming and the Scrum are the two popular process model referring agile modeling in the software community. Then we have component based process model. You might have heard about the language COM and DCOM, that is part of component based software engineering. We have the formal process model, we have concurrent process model, we have aspect oriented software development process model. We will take up one by one. The most popular process model is agile process model. Agile is not a new thing. It has been in the practice in the manufacturing industry, and this is the Agile Manifesto. Manifesto means promise. Manifesto means promise, and this promise says that at the time of process creation, at the time of software development, if you will follow these rules, then your software would be of very high quality. And what are those rules? Those rules are individuals and interaction over process and tools. Process and tools, in the conventional process model, we heavily rely on the process and tools, and we ignore the individuals and the interaction. So in the any process model which is conventional, we first create the process, then we procure the tools before start of the software creation. But in the agile process, we don't rely much on the process and the tools, rather we give emphasis on the individual. Suppose there is a good coder, then all the coding would revolve among that particular individuals. And the interaction means face to face communication. In the conventional process model, we don't value the face to face communication much. We document everything, but here we don't document. We do in the extreme programming, we do meeting twice. In the Scrum, we keep meeting in the morning and the evening, and we develop the software 24/7. So individual and interaction, whenever you will value the individual and the interaction, the software quality would be of very high quality. And the next is, in the traditional process model, we value the comprehensive documentation. Anything you write, you do any coding, you document that. You write any test cases, you document that. You follow any algorithm, you document. You have to document that. Otherwise, quality people will not pass your phase. But here, from the first day, we create the working software. From the first day, whatever we think, we create that day only. Or because in the unconventional process model, quick releases are facilitated. In the conventional process model, the releases are delayed. And in the conventional process model, we do the contract negotiation. Means in the contract, the customer and the vendor, client and the vendor, they are the two entities. And a client has to procure the software, they have to release the checks, and the vendor has to install the software. So, they are the two entities. So, at the time of installation of the software, a lot of dissatisfaction happens automatically, because the client think they are not the part of the software development. It is the responsibility of the developer to create the software and to deliver the software. And the developer thinks that the clients will never be satisfied whatever you do. So, such problems hamper the project to some extent. So, in the agile process model, we facilitate the customer collaboration. Means the team of customer as well as the vendor is created. So, on the daily basis, the customer is seeing the progress of the projects. So, at the time of installation, the customer will never tell कि these are the lacunas or they wanted the project in this particular fashion. So, because there is a collaboration and customers people are a part of team and they watch the progress of the project on the daily or the hourly basis, and whenever they think कि there should be some changes, they do it immediately, but which is not done in the case of conventional process model. So, customer collaboration is very, very important. Similarly, in conventional process model, we follow a plan. First, we create a plan and we do the work according to the plan document in the same way, but and in between, if new work comes, new changes comes, we do not respond to that. This is the standard techniques of the conventional process model. Otherwise, you cannot carry out the conventional process model. But what we do here, at any phases, any time, if any change is coming from the client or through the customers, vendors observation, that is immediately incorporated. So, in the unconventional process model, which is agile, agile is one of the popular unconventional process model. We value individuals and interaction, we create the working software from the first day, we do the customer collaboration and we respond to the change from any time. Then the quality of the software is bound to be very, very good. There are different types of, by referring to this Agile Manifesto, you can create your own Agile process model, and there are 13 and 14 Agile process model available in the market, referred by various companies. Among that, two are very, very popular. One is called Extreme Programming Process Model and other is called Scrum Process Model. Now, in the extreme programming process model, what is done? First, the user stories are created. User stories means, suppose they divide the work in the name of stories. So, suppose there are 100 stories, means 100 planning, you can say 100 planning. So, user stories means in this particular phase iteration, the team will clear 100 stories, means 100 planning. So, first the user stories are created in the story cards. So, team is very clear from the first day that in this iteration, and the iteration cycle can be of 2 weeks to 3 months. So, iteration cycles are small. So, releases are small in the case of agile process model. So, in this iteration the team is very clear that they would clear 100 stories or 100 planning, and they, because among the 100 stories they need to value them, they need to prioritize them. So, they prioritize them from 0, 1, 2 up to 99. Then the acceptance criteria, because the customer as a part of team, so acceptance criteria is decided there even the phases starts. And the iteration plan, the team the team is very clear that in how many iteration they have to deliver the software. Suppose they want to deliver the software in 1 year, then they can keep 12 iteration cycle. So, they will release the project or the product in every month. So, initially the user stories are created, then their values are prioritized, then the acceptance criteria is decided, and the iteration plan is fixed. Then after this planning phase, the team do the designing. Designing means in the conventional process model we create the architectural design, which is the high level design, and we create the detailed design, which is the low level design. So, a lot of time, and those design documents are referred by the team of coder and the tester for the unit testing and the coding as well as the integration testing. But here that is not desired. Here the quick designs, quick or simple designs, because we have the user storage in the CRC card. So, simple design is done, and if there is any spikes, discrepancy is coming, that is observed, so that would be immediately resolved there, and through referring to that design the coding would be started immediately. So, in the Agile's popular extreme programming process, after planning the quick designs are released and coding is followed up. But here two important coding techniques are used. One is called the refactoring and other is called the pair programming. Refactoring means without hampering the project execution, you are changing the code. From the user points of view, user will never visualize that the project's code has been changed. For example, so you take any project, you take the example of railway reservation system. It is started in 90s, but at that the first version of the railway reservation system is created in Fortran, but now nobody creates use Fortran language. So, the environment is completely changed. These days we use the .NET framework. So, but could you see that railway reservation system has been stopped for a single day? No. So, the refactoring technique has been applied. So, without the hampering the execution of the project and the product, the codes are refactored or the restructured. This technique is used, and the concept or pair programming. Pair programming means on a module 2 or 3 programmers, more than one programmers are working together. One agile team is of very to be a part of the agile team, you should have the experience of 7 to 8 years minimum. Otherwise, you cannot be a part of agile team, because all the experts, coder, tester, planner and the designers, they are the part of the team. So, they have all the historical data available with them. So, the handling of the pair programming is very easy for them, which is not in the case of conventional process model. So, here we apply the concept of refactoring, pair programming, and the continuous integration is must for the quick delivery. Continuous integration means in the modular approach of programming, what we do, we create one module, and after creation of that module we test that, then we do the integration testing, and with every integration testing we do the regression testing. But here a lot of time is wasted. So, here immediately by using the high level concept of pair programming and the refactoring, the code would be created, and whenever needed integration would be done immediately, followed by the regression testing. Whenever you do any integration, the side effect is generated, and for that you need the regression testing, which is very costly in the case of conventional process model, which is very easy here in the case of unconventional process model. And after that, the testing by the independent test group ITG would be done immediately, and the based on the acceptance criteria, the first release of the project is complete. Now suppose we have started this project with the 100 user storage, because the delivery date is scheduled earlier. So suppose 1 month, we have kept 1 month for the delivery date, and within 1 month out of those 100 only 80 storage could be cleared. Then what is the velocity? So project velocity means 80 by 100, it is 80%. So initially we have, the team has thought of to clear 100 storage. Now they could clear the 80 storage only, but they will not deviate the delivery time. So they have to deliver the software, release the software within the stipulated time. So they will release the software with the 80 storage only, then velocity is 80%. So in the next release, the team will think to increase the velocity, it should be 90% or the 95%, they will keep a target of that. So in the next release, what they will do? So they will take up total 100 storage, of course, because this was the backlog, we had the backlog of 20, so 80 new storage the team will take. So now team will update in the planning phase, design phase, coding phase by introducing most expert trainer, by introducing any tool, by any means. They will revisit all the lacunas of the previous phases, and they will clear the 100 phases with the 95% of velocity. This way, so that the final release should not be hampered. This is the extreme programming technique. This is the very, very popular agile technique. But generally the extreme programming technique is known as the ideal technique. Most of the software company, application software company, they still do not prefer the extreme programming technique, they go for the Scrum technique. There is not much difference between the extreme programming and the Scrum. What we do, Scrum means the storage. Here we will call the storage would be called the sprints. Suppose earlier we have said 100 storage, here we will say 100 sprints, and instead of one meeting we will keep 2 meetings, and extreme programming works for 8 hours or 9 hours, but in the case of Scrum we will keep the project going on for 24 hours. So instead of 1 shift we will keep the 3 shift. So in the Scrum processes, what are the significant thing? The one significant thing is that the process would be done in 3 shifts, means it will not stop. So there should be very good team coordination shift wise, because in the first shift the people or the software developers should create something, and that should be resumed by the second shift people, and it should be carried out and it should be given to the third shift people, so that the project progress is not hampered. It is done 24 hours. So here what is done, the backlogs are not kept. In the case of extreme programming we have kept the backlogs, but here all the backlogs would be cleared immediately. So and Scrum meetings would be done twice. So face to face meeting, in the morning meeting the team will plan what they have to do today. In the evening meeting they will visit what they have done, what they need. So immediately, because the team is working for 24 hours with a proper coordination, so this 2 times meeting will benefit them. So the quality of the Scrum process model is very, very high. and we have another process model in the unconventional, which is very popular, is called the component process model. And we have so many languages based on the component process model. Here the concept is to increase the reusability. Reusability means, suppose a company is writing a code and for the banking projects, but there are so many software companies, they are working on the banking project. So, do not you think that they are wasting their time to writing the same code again and again? Maybe for the commercial viability they need to write it, but it is a wastage of human effort. So, it would be better that they will write a component, they will write a code and they will keep it in the form of component which can be hooked by any programmer whenever needed, and this is exactly done in the component based programming approach. We have two types of components, was the internal components and the external components, and the internal components are used by the only people or the team members of the same company, and the external components can be used by the another company also. So, in the component based programming approach, what is done, the library of components are created, and whenever you need to write the same code, repetition of the code again and again, it is good to hook the component from the library and you fit it into your program, and this is exactly the base of the component based programming software engineering. So, it is very popular method, and most of the companies are using the component based programming technique for the in-house projects, because they have the repository of components in-house, and among they share those components among different projects. So, reusability is increased, and through the increase of the reusability, what is done, the mean time of the programmer or the tester is given in the core work and not in the repeated work. Similarly, we have another process model, the formal process model, which is the unconventional process model, and this formal process model is a very new process model. It is specifically used in the research project. For application project, we know, the team know what they have to develop, because they are mapping a business. So, they are mapping different functionality, they have to create the different functionality. So, the team is very clear about the functionality. But suppose if you are writing a system program, if you are writing any utility, then the conventional techniques would not be used, or the conventional specification technique, rather I should say, would not be used. There the formal method is popular. For example, in operating system, you know what are the main things. In operating system, you do the memory management, you do the process management, you do the secondary memory management, you do the file handling. These are the standard functionality of the operating system. Similarly, in the compiler, the functionalities are fixed. You do the code optimization, you do the code creation, like that. So, in utilities, the number of functions are more or less fixed. So, if you want to create, if the team is creating a new operating system, more or less the functionalities are fixed, but they want to improve or enhance the performance of the functionality or enhance the capability of the operating system. So, they have only few requirements. So, in the memory, if through some technique, if the team is increasing the speed of the operating system, so it is worth. So, in that case, the specification is not done in the case of conventional techniques, which we are doing in the case of conventional process model as well as in the case of unconventional process model. So, up to design phase there are two phases, one is specification and the other is design. So, architectural design and the low level design. So, more or less for these two approaches we follow the traditional techniques, but in the formal method specification, the specification technique changes. So, we have Z specification techniques, we have clean room testing techniques in the formal specification method, which is exclusively used for the research project, compiler development, operating system development and on these sort of things. Similarly, we have concurrent methods, which is the unconventional techniques. We have aspect oriented software development technique, which is based on the delivery of the application software for artificial intelligence sort of thing. So, we have many, and you can devise your own unconventional technique and your own conventional technique. So, what we have learned throughout the session? Throughout the session, कि SDLC software development life cycle, the phases are fixed. Whatever process model you are following, you have to consciously or unconsciously incorporate all those phases. So, what we do in the conventional process model, we use different approach to clear those phases, but in the unconventional process model, we fine tune those phases and we develop the matrix, how to check these things, to develop the matrix. For example, in the software, what are the major metrics? The major metrics are line of code, function point and the feature point. In the case of other projects, the measurement is very easy, but in the case of software, because of the intangible behavior of the software, the measurement is a very tedious work. How would you plan for the cost of the software? It is not easy, and the visible things are line of code only. But suppose two programmers are writing the line of code, the quality of code, suppose one programmer's line of code, they have written 100 line of codes and the other programmer has written 50 line of codes. So, if you will count the line of code, the first programmer should be paid more, but the quality of the second programmer can be good. So, this type of problem comes specifically in the case of high level programming languages. So, line of code is a good measurement when you go for assembly language programming or the machine language programming. So, for traffic light controller, we generally use the assembly language programming. So, there the line of control is a suitable matrix, which is not good in the case of high level languages because of the language complexity. So, even that is why we go for the function point approach. In the function point approach, instead of line of code, the team value the number of functions which has been created, then they settle the cost. But even in the function point approach, we do not follow the time complexity of the function, because there can be different types of functions, input function, output function, like that. So, there we follow the feature point matrix. So, in the software project, the line of code techniques, function point techniques and the feature point techniques, they are the only visible matrix which is applied on all the project, whether it is a conventional project or the unconventional project.
On that note, I would like to thank sir for this very enriching lecture, and I would like to thank you, dear friends, for watching our show. Stay tuned and keep watching. Thank you.
Thank you, ma'am. Thank you, ma'am.